These are the notes for 5.1, part 1, and this section is all about polynomials. And this part 1 that we're going to do today, it's just a lot of vocab. So be prepared to write a lot of vocab. The examples are basically just asking about the vocab. So I'm going to try and go fast because it's kind of a lot of notes. Mine took me a front, a back, and then another front of a page. Usually it only takes a front and a back. So let's see if we can speed through this. All right, so the first thing we're going to talk about is a term in math, and we're going to talk about terms within polynomials. So a term is something that it's being added or subtracted, basically. So for example, let's just write down an example like this. 3x squared plus 2xy plus 7. This is a polynomial, and it is made up of 3 terms. So 3x squared is a term, 2xy is a term, and 7 is a term. So a term is something that could have variables with it. It could have a coefficient out in front, like a number, like a 2 and this 2xy. Those are all 3 terms. So a polynomial is something that is made up of 1 or more terms. So a certain kind of term is called a monomial. So that's one of our first vocab words here. A monomial, think of mono, 1. A monomial has only 1 term. And that term has to be a product of constants and variables. All right, so what I'm going to do as I go through this today is I'm going to highlight the words that are vocab words. So monomial is a vocab word, and so is term. You might want to do the same thing to help you see those important words. So a monomial is something that has only 1 term. So when we get a little bigger, a polynomial, poly means many. Now in this case, it doesn't have to be many. It could just be 1 monomial, or it could be a sum or difference of a bunch of monomials. So a polynomial is either a monomial, which is just 1 term, or a sum of monomials. So it could be a bunch of monomials added together. So that polynomial is another vocab word here. So this, what we saw right up here, that's a polynomial. 3x squared plus 2xy plus 7, that's a polynomial. Now, even just 2xy on its own would also be a polynomial. It's just 1 monomial. So we're going to look at some examples of polynomials and things that are not polynomials. All right, so on this side over here, I'm going to do things that are polynomials. And then on this side over here, we're going to do things that are not polynomials. So some examples of polynomials would be something like 3a plus 2. That's a polynomial. Has 2 terms, 3a and 2. Another example of a polynomial would be something like 1/2 x squared. That's a polynomial. Even though there's only 1 term, it's okay. It's still considered a polynomial. Something like negative 3t squared plus t minus 5. That has 3 terms, and it's a polynomial. Something as simple as x by itself, that's a polynomial. And even just a number like 0 or 5 or 1, that's considered a polynomial. So polynomials include a lot of things, but there are some things that are not polynomials, and I'm going to write down 3 examples of those. So the first 2 are going to look kind of similar. One thing that's not a polynomial would be something like this: x plus 3 divided by x minus 4. And another thing kind of like that that's also not a polynomial is something like 1 over x to the 3 minus 2. It's that big fraction that's making it not a polynomial. So the reason those two things are not polynomial is because they're not a sum of terms. Okay, there's division in there between those terms, so those are not polynomials. Polynomials need to have adding and subtracting between every term. Something else that's an example of something that's not a polynomial is something like this. 5x to the 3 minus 2x squared. That's okay so far, but then I'm going to put plus 1 over x. This is not a polynomial because 1 over x isn't considered a term because it has that x on the bottom. It's being divided, so it's not a polynomial. I'll be honest, I've never seen that before, that's not a polynomial. But according to our book, it's not a polynomial. So the first kind of example we're going to do is I'm going to write a polynomial on the board, and you're going to have to tell me what the terms are. So I'm going to go to the next page here. Pause if you need to. All right, so the first kind of example you guys are going to have to do in class today, it's going to say identify the terms, and then it's going to give you a polynomial. So here's the one we're going to do. Here's the polynomial. 3t to the 4th minus 5t to the 6th minus 4t plus 2. And we're going to list out all the terms. I want you to put big spaces between these. Don't make me guess what your terms are. So the terms are the things that are separated by adding or subtracting, even though subtracting is really just adding a negative. So keep that in mind. So our first term is this 3t to the 4th. That's a term. Our second term is negative 5t to the 6th. So make sure you keep that negative in there. Negative 5t to the 6th. Our third term is right here, negative 4t. And then our last term is right here, 2. So this polynomial has 4 terms. They're all being added or subtracted. It's pretty easy. That's the key to finding the terms. Now, this polynomial has 4 terms, so it doesn't really have a special name, but some polynomials do get special names. We're going to write those on the next page here. So these are special names for polynomials. All right, so I'm going to make kind of like a little chart here. We're going to look at how many terms the polynomial has and then what its name is. And we've actually already talked about one of these. So we're going to need 1, 2, 3, 4 spots on this chart. So if a polynomial only has one term, we call it a monomial. It's also a polynomial, but more specifically, we could call it a monomial. If something has 2 terms, we call it a binomial, like a bicycle with 2 wheels. Binomial, 2 terms. If something has 3 terms, we call it a trinomial, like a tricycle with 3 wheels. Now, all the things that have 4 or more terms, those poor guys, they don't have any special name. Sorry. So just 1, 2, and 3 termed polynomials get a special name. So the next thing we're going to talk about is the degree of a term. So I'm going to go to the next page here. So let's write down the definition here. It's our next vocab word. The degree, and that's a vocab word. Let's highlight it. The degree of a term. So remember, a term is something like 3x squared. So the degree of a term is the number of variable is like a letter, the number of variable factors in that term. Pause for a second if you need to write that down. It sounds confusing, but it's really not too bad. We're going to do a bunch of examples, and I think you'll see what I mean here. So I'm going to list a bunch of terms on this side of my chart, and then over here, I'm going to write the degree of that term. So I'm going to ask you, what's the degree of this term? So our first one we're going to do is 7t squared. So in this, the variable is t, and there's two of them, t times t, or t squared. So the degree here is 2. Okay, it kind of came from that 2 right there. They're going to get more complicated than that, but we could also have something like 8x to the 4. X is the variable. There's 4 of them, so the degree is 4. That came from right there. See, it's pretty easy. We could have something as simple as 3x. So if you remember, that x really has a little 1 on it. You just can't see it. So its degree is 1. There's just one variable there. You could even have something that has no letters on it, like just a number or a constant, like 7. That has a degree of 0 because it has no variable factors. Now let's do one that's a little bit more complicated like this. 9x squared y z to the 4th. So remember, a degree takes into account all the variable factors. Doesn't matter what letter they are. So this one has 2 from the x, 4 from the z, and technically 1 from the y. So altogether it has 2, 3, 4, 5, 6, 7. 7 is the total degree of that term because we add up all the variable factors. It doesn't matter what letter they are. So that's what a degree is. Now on the next slide, we're going to talk about a word that you've heard a lot. It's coefficient. That's our next vocab word. All right, so when we talk about a term, its constant is the coefficient. So the part of a term that is a constant factor is the coefficient. And coefficient is the word I'm going to highlight there. Coefficients are also a pretty easy thing. It's just that this is a lot of vocab, so it's kind of a lot to take in. Coefficient. So again, we're going to do like a little chart of, I'm going to give you a term, and we're going to figure out what the coefficient of it is. So for example, a term like 4x to the 3, the constant in that term is the 4. It's like the number out in front. So the coefficient there is 4. We use coefficient. We use this word all the time this year. Let's say you have a term like negative 7x squared y. Doesn't matter what the letters on it are. We just look at the number out in front if we're looking for the coefficient. So the coefficient here is negative 7. If we have just a variable, like if you just see an x, remember that it technically has a 1 out in front. That's technically 1x. So x's coefficient is 1. And then let's say you have just like a constant, like just negative 8. That means that's the coefficient. We just considered that the coefficient itself. So that is what coefficients are. So now we're going to talk about parts of a polynomial, so terms and coefficients and degrees, and how they factor into a big polynomial. So I'm going to go to the next page here. So I'm actually gonna type something really quick here because it'll just look a lot neater if I type it. So what we're going to write here is the leading term of a polynomial, and that's our next vocab word, leading term. The leading term of a polynomial is the term of highest degree. We're going to write a couple more things here. So that term that has the highest degree, so it has like the most letters on it, that's the leading term, and that term's coefficient, so its coefficient is called the leading coefficient. And then that term with the most variable parts, the highest degree term, which is the leading term, its degree is the degree of the whole polynomial. And its degree is the degree of the polynomial. So you guys go ahead and pause if you need some more time to write that. I'm just going to highlight the vocab words here. So the vocab words are leading term. We're going to have to figure out what the leading term is. And then when you find the leading term, its coefficient is the leading coefficient, and its degree is considered the degree of the whole polynomial. So we're going to do an example down here. We're going to make like a kind of a chart again here. So I'm going to give you a big polynomial as in our example. 3x squared minus 8x cubed plus 5x to the fourth plus 7x minus 6. It's a long polynomial. The first thing I'm going to do here is I'm going to make a chart. So I'm going to kind of keep this nice. I'm going to list out all the terms in this polynomial. So the terms I have are 3x squared, negative 8x to the 3, 5x to the fourth, 7x, and negative 6. Those are all the terms of that polynomial. So now what we're going to look for is the leading term of that polynomial. That's the one with the highest degree. So let's write down what the degree of each term is. So the degree is the number of variable parts, the number of variable factors. So this first one, the degree is 2 because of that 2 right there. The second term, its degree is 3 because of that 3. This one's degree is 4 because of that 4. 7x's degree is 1 because there's technically a little 1 on that x. And negative 6, its degree is 0. So we already know that the leading term of this polynomial is the one with the highest degree. The highest degree was 4, so we know that this is the leading term. We'll write that in just a second. I also want to talk about the coefficient because we're going to talk about what the leading coefficient is. So let's write down the coefficient of each of these terms. So this first one's coefficient is 3 because it's 3x squared. This one is negative 8 because it's negative 8x to the 3. This one's coefficient is 5, 7, and negative 6. So if we were going to talk about this whole polynomial and I asked you what the leading term was, it's the term with the highest degree. And the term with the highest degree was right here, 5x to the fourth. So that is our leading term. So that means that if I asked you, what's the leading coefficient of that big polynomial we wrote? The leading coefficient is the coefficient of that leading term. So the leading coefficient is 5. And then if I asked you what's the degree of that whole polynomial I wrote up here, the degree is the degree of the highest term, or of the leading term. So the degree of this polynomial is 4, because the degree of the leading term was 4. All right, we have 2 more examples to do. So sometimes what your book is going to ask you to do is to arrange a polynomial into ascending order. It's going to say arrange in ascending. That means from small to big order. And what they mean when they're talking about that is they're looking at the degree of that polynomial, or the degree of the terms. So for example, here's a polynomial we're going to arrange in ascending order. 12 plus 2x to the 3 minus 7x plus x squared. So we want to make our degrees go from smallest to biggest. So our smallest degree is the one with no x at all. It's this guy. So that's the smallest. Let's see, do we have any terms with an x degree of 1? I think so. This term, the x degree is only 1, so that one comes next. So we're going to write minus 7x because it's a negative 7x. Our next highest degree is x squared, and it's positive, so we're going to write plus x squared. And then lastly, our highest degree term is 2x to the 3. So we're going to write plus 2x to the 3. So we just rewrote that polynomial in a different order. We still have pluses and minuses between everything, but the terms go from smallest to biggest. Now, sometimes instead of ascending order, we're going to go in descending powers of x. or y, or whatever letter they tell you. So for example, we're going to do another one down here. And it's going to say arrange in descending powers of x. And here's the polynomial we're going to arrange. Y to the fourth plus 2 minus 5x squared plus 3x3y plus 7xy squared. Whew, that's a long polynomial. Now we're going to arrange this. We're really only worried about the x powers. We're going to arrange it descending. That means from big to small. We're getting smaller. Descend powers of x. So the highest power of x that I see is this power of 3 right here. So that's going to be my first term when I rewrite it. 3x cubed y. Now if I go down, let's see, down from 3, there's a 2. There's a power of 2 with an x. So that's going to come next, minus 5x squared. And then let's see, do I have any 1 powers of x? This last term right here is a 1 power of x. So I'm going to write plus 7xy squared. I'm not really worried about the y's here. I'm only worried about the x. Now, these last two terms, neither of them have an x. So it doesn't really matter which way you write it. Usually you write any constants, like this 2 at the very end. So I'm going to do plus y to the fourth next. And then last, I'm going to write the plus 2 because in general, we like to write numbers that are just constants at the very end. All right, I think that's enough vocab for one day. So that's all our notes for today. Come to class with questions and ready to do some homework on it.